So let's discuss the next obstacle force, which is an angular acceleration force. And again, this is an imaginary force that we apply on the vehicle towards the backside of the vehicle. And intuitively, you will not able to visualize this force, but let me help you. So let's say you are observing this overall car from a distance, and all you see, the car is trying to go linearly, let's say 0 to 100 kmph in just 10 seconds. So there are components inside the car. For an example, the rotor of the motor or gear or an axle or a wheel are also trying to rotate from, let's say, for an example, rotor of the motor, they are also trying to rotate from 0 to, let's say, 10,000 rpm in the same amount of time, which is 10 seconds, which means that now motor has to deliver power or energy not only just for accelerate the vehicle from, let's say, 0 to 100 kmph, but also it has to deliver the additional power to rotate this component from 0 to the respective rpm. And hence this extra power that motor is delivering, we define in some sort of obstacle force which are acting on the vehicle, and that obstacle force we call it as a angular acceleration force. Now that we understood what is angular acceleration force, now the only remaining thing is to calculate the amount of angular acceleration force. So here I will take an example of rotating component wheel. So let's say this is the wheel and whose radius is rw and having an angular acceleration alpha. So in the linear system, what we know, F is equal to ma, where a is the linear acceleration. For rotating system, the F is replaced by the torque and m is replaced by the inertia of the component. And here, instead of linear acceleration, we write the angular acceleration. Now we can replace this torque with this formula, which is rw multiplied by F is equal to inertia, and angular acceleration we can replace by the linear acceleration divided by rw. So now the force will be equal to 1 by square of the wheel of the radius multiplied by inertia multiplied by a. So if you see here, the amount of angular acceleration force which I have written is m equivalent multiplied by acceleration. What is m equivalent here? So m equivalent in the case of wheel is going to be 1 by square of the radius of the wheel multiplied by the inertia. But there are another component which are there inside the vehicle, for example rotor of the motor or gear and axle, and for each component we have to calculate this m equivalent, and hence I have written in a general formula here, which is equal to 1 by the square of the radius of the wheel multiplied by the summation of inertia of respective component divided by the square of the gear ratio of respective component. So just for completeness, again here a is nothing but the linear acceleration of the vehicle, and I is the moment of inertia of respective component, and rw is the radius of the wheel, and n is the gear ratio. And just to again emphasize it, this gear ratio will be different for all the components. Let's say for an example, gear ratio for rotor with respect to wheel, let's say it will be 13, then the gear ratio for any gear with respect to the wheel, it will be less than 13. So we need to calculate the gear ratio for respective component, and we will put in this formula, and we will get the equivalent mass. And if we multiply this equivalent mass with the linear acceleration, we will get the net angular acceleration force, and the direction of that force will be towards the back side of the vehicle. So this is all about the angular acceleration force.